Alright, hello guys, welcome to Code Off, and today we are going to see a practice problem on the recursion series for competitive programming. Now, in this series, what we are going to do is we are going to discuss three basic problems, 5 medium level problems and 2 hard problems to get comfortable in recursion. Because when we get started with the dynamic programming series, I want recursion to be the because recursion is the base of the dynamic programming, so I need all of you guys to be comfortable with recursion. So let's get started. So this problem is a basic problem. So what the given problem states is, given a string, count how many vowels are present in the string. It's a totally basic problem, and I want the iterative approach is pretty much easy, but what the recursion approach is what we need to develop here. Okay, so let's start. Let's say we are given as input string of code of, and what we want is we want to count how many vowels are present in the string. So the simple way is to start from the first character, traverse to the whole string, and check if it's a if that character is vowel or not, and increase the count. So the follow-up here is that can we do this using recursion? So let's see now. Okay, let's do the first iterative approach. Now in iterative approach, we check every character of the string. So let's suppose we start from the first character. So let's see, we got C, then we got O. C was not a vowel, O is a vowel, so we increase our count. D is not a vowel, E is another vowel, so we increase our count again. O is another vowel, so we increase the count. F is not a vowel, F is not a vowel, so and at last we get our count to be equals to 3. So that means in iterative approach, we start from the first character and we traverse to the whole string and we check if it's a vowel or not. Similar kind of approach is follows in the recursion function, but what we need to do is we need to go step by step, as we discussed in the previous videos, that how to approach a recursive function. But let's first see the code for an iterative approach. We are given a string and we are given a set of vowels, that is A, E, I, O, U, and we traverse over the whole string and we check if that character is vowel or not, so we increase the count. So it's an iterative approach, but let's check the how to find the recursive solution for this problem. So what we do is first we define our base condition. Now what was our base condition when we were approaching the iterative approach? The base condition was that when we reach our pointer, that is when we reach to the end of the string, then we stop the loop, right? So here also a base condition is similar. We start from the current character, that is 0th character, and then we traverse to the whole string and we see if we reach the end of the string or not. So similarly, this is our base condition, that is if we reach to the end of the string, we return, right? So what's the step 2 is to think about the recurrence relation, right? So as let's see now, in iterative, what we try to do is we try to check every other character, right? So in recursion, what could be our recursion relation here too? We'll start from the 0th character, we will check if it's a vowel, so we will pause that state, and then we will check for our next character, we will pause that state also, and similarly we will traverse the whole string. Now when you draw your recursion tree, you will get the point that how your recursion function should follow and how your recursion relation will be. So let's see. Okay, so step 3 is draw a tree diagram, and it's very important. So make sure you whenever you code a recursion function, you always draw a tree diagram, because that will explain how should you approach to how should you code the whole recursion function. So we start from the current character and check every next character. So our given string is right now is code. So we start from C, and we start from C, and our initial count is 0. So that's why it's given as 0. we then have have a choice of going next, and we pause our state where our current count is still 0, and we have another choice, that is we go next into an next character, that is O. We again traverse the string, we check D, is it a vowel or not, and we pause our count state because it's still not processed, that is we still not in our base condition. We again go forward, and as soon as we reach the end, that is E, we reach our base condition. So now as we reach our base condition, we will check if this is a vowel or not. So E is a vowel, so we return back this child function to our parent function, which is the D. Okay, so we will return 1 to D, that is we will return our int to our D. Now D will check if it's a vowel or not. As it's not a vowel, so it will add up to the return function from E, so it will return 1 to its parent function, which was O. And again we will check if it's O is vowel or not. If it's a vowel, so it will add to the integer we got from our child, that is 1. So it will add 1 plus 1, that is O is also vowel, so it will add 2, and it will return its call to the parent function. It will then check if C is a vowel or not. As C is not a vowel, so it will just return 2 to its parent function. Now as C was our first character, so as we return to our parent function, so at last it will come out of the whole function. So now just we need to write the recursion code. Now as you can see, this is just simple approach. As we define our base condition, if our n, that is our pointer, reaches to the size of the string, that is end of the string, so we will check if it's a vowel or not. If it's a vowel, we will return that state. If it's a vowel, then we will return 1. If it's not a vowel, then we will return 0. So when we return 1, so it will add to the parent function, which is number of vowels s of n plus 1. So this was the recursion code. So make sure you try to draw a tree diagram, because tree diagram is necessary, because it will tell you like how should your relation behaves, how will your relation will form recursion relation, how will your recursion relation form. So whenever you code for recursion function, you should always draw a tree diagram, because it's necessary. Okay, so this was just a recursion code, and that's how we approach to a recursion problem. It was a basic problem. So that's it, guys. So we will get another basic problem, that is 2 basic problems are still remaining. Then we got 5 medium and 2 hard problems before we end this recursion series, or maybe there might be some theory also in this series. So make sure you follow the whole series, because it's important that you don't skip any part, because if you directly jump to a intermediate problem, then it might be hard to grasp the whole problem. So make sure you follow the whole series, and that's it, guys. Follow, share and subscribe. Cheers.